Hello everyone. Welcome to my channel Chemistry by ANR. Today's topic is valence bond theory. It was actually introduced by Hitler and London in the year 1927, and it was developed by Pauling and other scientists as well. This theory was also known as the orbital concept of bonding, because it was actually assumed that in a bonding scenario there occurs overlap of orbitals. As for example, if we consider two hydrogen atoms and we tag them as HA and HB, and when they are forming a chemical bond, it is assumed that two hydrogen atoms are approaching each other. They are coming in close proximity to one another. Then what happens is the nucleus of one hydrogen atom exerts an attractive interaction to the electron cloud of the other. So if I say nucleus of hydrogen atom A, it will exert attractive interaction to the electron cloud of hydrogen B, and nucleus of hydrogen B will exert attractive interaction to the electron cloud of hydrogen A. So there occurs attractive interaction as well as repulsive interaction. Why repulsive interaction? Because when two hydrogen atoms are approaching, the nucleus of one will actually experience a repulsion from the nucleus of the other if they come too close. Then electron cloud of one will experience a repulsive interaction with the electron cloud of other if it comes too close. So actually there are two types of interaction. One is the attractive forces, attractive interaction between nucleus of one to the electron cloud of itself, and nucleus of one to the electron cloud of the other. There is repulsive forces of interaction between electron clouds of two hydrogen atoms, and there is repulsive interaction between the nucleus of two hydrogen atoms. In a bonding scenario, always remember the attractive interaction should actually be more stable than the repulsive interaction. That means energetically what should happen is the attractive interaction, on account of the attractive interaction, there should be release of energy. There should be stabilization. Here the dotted lines we can see, they are the old forces that exist between HA nucleus to the electron cloud of HA. These dotted lines are the attractive interaction between the nucleus of B to the electron cloud of B. Now, in a bonding scenario, when the two atoms are approaching each other, then there occurs attractive interaction between the nucleus of A to the electron cloud of B, and between the nucleus of B to the electron cloud of A. So this is the diagram. And here we can see the attractive interaction and the repulsive interaction. Why repulsive interaction? Two positive nucleus when approaches will repulse. Two electron cloud when approaches will obviously repulse. So what happens is, this is the energy profile. Let us understand the energy profile. You visualize it from right to left. Okay. So you visualize it from right to left. How? If we assume these are the two hydrogen atoms, they are approaching, they are coming closer, means the distance of separation between the two is decreasing. So when the distance is decreasing, we can see the energy is becoming lower and lower and lower, and there occurs a minimum condition, minimum energy, where the bonding of the atomic orbitals are occurring. And there is a region which is common to both, and this is the overlapping region of the atomic orbitals. And the energy, the decrease in energy, is the bond energy for the formation of 1 mole of such bonds. So this is the potential energy curve for the formation of H2 molecule. Again, let us see that when the two atoms of H, one A and B, they come closer and they try to form a chemical bond, they try to overlap, the attractive interaction should be more stable than it should actually energetically supersede the repulsive interaction. Attractive interaction is always stabilization, repulsive interaction is always destabilization. So the net stabilization should be greater than the net destabilization. Under that situation, there occurs overlap of orbitals, there occurs lowering of energy, and the lowering of energy is known as the bond energy. Next, moving on to the orbital overlap concept. So just now I said the atomic orbitals, they approach each other and there is a partial merging of atomic orbitals which is known as overlapping, and under this overlapping scenario, the covalent bond occurs. Always remember, the extent of overlap decides the strength of covalent bond. That means if the region of overlap is more, then the strength of the covalent bond is also greater. So the partial merging that we have seen of atomic orbitals is this area, and this is the bonding area. So here the covalent bond is occurring because the atomic orbitals are partially merging. And in this zone, there occurs pairing of electrons. So two unpaired electron from each, I'll say from each atomic orbital, there will be one unpaired electron, and in this zone, the pairing of the electrons occur. Okay, so next, therefore, according to the orbital overlap concept, that is as per VBT is only the orbital overlap concept. The formation of the covalent bond between two atoms results in pairing of electrons present in the valence shell having opposite spin. So the two electrons that pair up should obviously be in opposite spin. Now the directional properties of bonds, what it is, the covalent bonds which are formed by the overlapping of orbitals due to the difference in the shape of the orbitals after the overlap, they actually have a definite geometry. They have a definite bond angle. So there occurs directional nature. Directional nature means tendency of the orbitals to have a particular orientation towards the axis. Now, overlapping of atomic orbitals like S and with S, P with P, or S with P. How does it occur? It can occur in a positive, negative, or zero manner. That means the overlap may be positive. What is a positive overlap? When the atomic orbitals are having same symmetry. They are in phase. When they are having same sign, they are supposed to have same symmetry, and it is known as they are in phase. Such an overlap is known as a positive overlap or in phase overlap. If the symmetry of one overlapping orbital and the symmetry of the other overlapping orbital are different, the sign is different, then they are actually overlapping out of phase. If this type of overlap, which is a head-on overlap, is known as a sigma overlap. And this type of overlap, which is a sideways or lateral overlap, is known as a pi overlap. However, again in a pi overlap, if there is overlap occurring between same symmetry orbitals, then it is in phase or positive overlap. If it is occurring between orbitals of different sign, different symmetry, they are out of phase overlap. So this is a sigma and pi overlap that has been shown. What does a zero overlap mean? Zero overlap is not a favorable orientation in order to form a bonding. That means it is a no bond scenario, out of phase scenario, which actually cannot result in any type of bonding. Neither I will say sigma nor pi overlap. Such an overlap is known as a zero overlap. So I hope the three types of overlap, the positive overlap, the negative overlap, and zero overlap is quite clear. Then, moving on to the types of overlapping. Just now I said there are two types of overlap. One is sigma and the other is pi. Sigma is always known as head-on overlap or end-to-end overlap. That is overlap of bonding orbitals along the internuclear axis. Now, it of course depends on the shape of the orbitals. S orbitals are spherically symmetrical. So when they are overlapping, this is your SS overlap and this is the region of overlap and it is a sigma overlap. S to P overlap along the internuclear axis will be this type of overlap and this is the region of overlap containing two unpaired electrons. And after the two unpaired electrons, of course, in the region of overlap gets paired up. Okay, now PP overlap is also like this. So this is the region of overlap. PP overlap, if it is a positive overlap, then it will be having same symmetry. If it is a negative overlap, it will be having different symmetry. Now, from this extent of overlap, SS overlap, SP overlap, and PP overlap, can you predict which of the overlap is a more strong overlap? Sigma bond is a more strong sigma bond? Just see, in a P lobe, it is easier to increase the extent of overlap. So a PP overlap is a stronger overlap than SP and then SS overlap. Why? Because S orbital is spherically symmetrical. To make two spheres overlap is not so easy. So the region of overlap becomes less. P orbital has a directional character. For that reason, the extent of overlap is greater. Moving on to a pi bond. Pi overlap is a lateral overlap. Okay, so this type of overlap occurs between atomic orbitals when the axis remains parallel to each other and perpendicular to the internuclear axis. So it is known as sideways overlap. And how the overlap takes place, let us see the diagram. This is the 2p overlap, p orbital overlap. When they come closer to each other, this is the region of the overlap. And we can see very less overlap is occurring by sideways overlap. And if we say this is the plane, this is the axis, then the overlap occurs in this manner. The pi bond is having a lobe, or rather the electron cloud is above and below the internuclear axis. So the strength of the sigma and pi bond, obviously the strength of both the bonds are different. Since the extent of overlap in a sigma is greater, always remember that a sigma bond is a stronger bond than a pi bond. So for that reason, a pi bond is more reactive because it is not as strong as a sigma bond. And whenever there is a multiple bond, suppose a carbon-carbon multiple bond we can see, then one will be sigma, rest will be pi, say pi 1 and pi 2. This is a triple bond. If I say carbon-carbon double bond, then also in that case, one will be sigma, the other will be pi. And wherever there is a single bond, it's of course a sigma overlap. This is a sigma overlap. Okay, so this is how atomic orbitals overlap. Now, if I say that there is a hydrogen atom here, then this hydrogen atom will show the overlap with its 1s and it will form a sigma overlap with the bonding orbital of the carbon. For that reason, we need to see the concept of hybridization, and our next concept in the next video will be hybridization. Till then, I hope the concept is clear to you. Please go through the book, NCERT book, minutely and post your doubt in the comment section.